In this episode, we are going to solve for eigenvalues and eigenvectors. So, in the previous episode, we dealt with a 2 by 2 matrix. Here, we are going to deal with a 3 by 3 matrix. Are we okay? So, we saw that the formula for finding the eigenvalues relating to the eigenvectors is giving us A minus lambda I multiplying this equal to 0, where we have our A as the given matrix and we have our lambda as the eigen value or the eigenvalues, and we have our I as our identity matrix. We also have this as our eigenvector or the eigenvectors. Are we okay? So once we know the relation here, we can straight away find the eigenvalues or the eigenvectors. And we know that in order to find our lambda, which is the eigenvalue, we are going to find the determinant of this matrix A minus lambda, the identity, and equate it to 0. This formula is going to help you find the eigenvalue for the corresponding matrix. Are you okay? For a 3 by 3 matrix, the identity matrix is written in this form where we have 1 0 0 0 1 0 and 0 0 1. Are you okay? So once we find the matrix minus this equal to 0, then we find the determinant of this. This equation is going to help us find the eigenvalues. Then we can also come back again and use the formula by putting in the value of the lambda we got and this equated to 0. This will help us to find the corresponding eigenvector straight away. So let's look at an example and how best we can solve this. So we have this example. Find the eigenvalues and eigenvectors for the matrix. So we have matrix A, which is 1 1 3 1 5 1, and we have 3 1 1. So let's look at how we can solve this. Here, for us to find the eigenvalue, where we call it this lambda, we are going to find the determinant of the matrix A minus lambda I and equate it to 0. This will help us to find the eigenvalue. Remember, this is a 3 by 3 matrix. Are we okay? So first, let's find an expression for matrix A minus lambda I and see how best we can do it. So the matrix is 1 1 3 1 5 1 3 1 1 minus we have lambda multiplying the identity 1 0 0 0 1 0 0 0 1. So this is the expression, and with this we can get our final matrix, which is A minus lambda I to be this form matrix. So this is going to give us a matrix 1 minus lambda. We have 1 and 3. These two we are going to get 1, and we are going to 5 minus lambda 1. Here we are going to get 3 1 and 1 minus lambda. So this is the matrix A minus lambda I. In order to find the eigenvalue lambda, we have to find the determinant of this matrix and equate it to 0. So how do we do it? So this is a 3 by 3 matrix. How to find the determinant of a 3 by 3 matrix? So I'm going to take one of the column and find the determinant. So first, I'm going to take this column. So I'm going to multiply 1 minus lambda it is going to be left with this matrix 5 minus lambda 1 1 and 1 minus lambda. So that is going to be, you can check out for our previous episode for a video on how to find the determinant of a 3 by 3 matrix. So this is going to be 1 by 1 for that. Then I'll choose this one. That will be negative 1. And that is going to be the corresponding matrix for the 2 by 2 determinant will be this minus 3. And I'm going to take the last 3. That will be plus 3. And the corresponding 2 by 2 determinant is 1 by 1. So we can multiply 5 minus lambda this way. Okay, so this is the expression for finding the determinant of this 3 by 3 matrix. So let's try to simplify this. We are going to get, so let's equate everything to 0. And if you simplify this, you are going to get 1 minus your lambda. And in this first bracket, you are going to get 5 minus 5 lambda minus lambda plus lambda square minus 1 minus 1. In this bracket, we are going to get 1 minus lambda minus 3. And plus, in this bracket, we are going to get 3, 1 minus 15 plus 3 lambda. Equates everything to 0. So I'm going to try to expand this bracket. And this is going to give me 5 minus 5 lambda minus lambda plus lambda square minus 1 minus 5 lambda plus 5 lambda square plus lambda square minus lambda cube plus lambda for that. So I'm going to expand this form, and that is also going to give me plus. We are going to have negative 1 plus lambda plus 3. Then the last bracket, that is going to give me plus 3 minus 45 plus 9 lambda. Everything is equal to 0. Now you group like terms and simplify the equation, and your equation is going to, so let's look at the final equation we are going to get from this expression. We are going to find our equation to be lambda cube minus 7 lambda square plus 36 equal to 0. This is our equation 2. So from this cubic equation, we can find 3 roots of the equation, and those roots will represent the eigenvalue. So you can use your calculator to find the root of this equation, and when you solve the root of this equation, is going to be lambda is equal to negative 2 and lambda is equal to 6 and lambda is equal to 3, like this. Are you okay? So we've been able to find the values of the eigenvalues. So you can conclude here that therefore the eigenvalues for the matrix are, we have negative 2, 6, and 3 as the eigenvalues. So the question asked for the corresponding eigenvector. So at an eigenvalue of negative 2, what is the corresponding eigenvector? At 6, what is the corresponding vector? And at 3, what is the corresponding vector? Let's move straight and find the corresponding vectors for each of the eigenvalues. So let's start with for our lambda equal to negative 2, which is, if the eigenvalue is negative 2, how do we find the eigenvector? We can find the eigenvector from the equation A minus the same lambda equal to 0, where this is the eigenvector. Are we okay? But all the same, we know that the expression for A minus lambda I is given as we have 1 minus lambda, we have 1, 3, we have 1, 5 minus lambda and 1. We have 3, 1 and 1 minus lambda. So let's represent the eigenvector by x, y, and z. Are we okay? Since it is a 3 by 3 matrix, we are going to get a 3 unknowns. So for lambda is equal to -2, let's make this as the first vector. So I'll call this x1, y1, and z1. And from the formula, it is equal to 0. Let's try to put in the value of, put in lambda is equal to -2, and let's look at the vector we are having. So we are going to get 1 minus lambda, which is 1 minus -2, and we are going to get 3. This is the vector we are going to get. The matrix is going to be this form, and we still have our 3, 1, 3. This is our vector x1, y1, and z1 equal to 0. So right here, if we want to find the value for x1, y1, and z1, we have many approaches of solving, but I will choose the elimination approach. So I'm going to use the elimination approach to solve, and you have to pay attention, the row operation. So here I'm going to still use the row operation by combining the matrix 3, 1, 3, 1, 7, 1, 3, 1, 3, 1, 3 by those here. So that will be 0. If everything is equal to 0, everything is equal to 0. And I'll try to manipulate the rows such that I'll get to a point I can solve for the value of x, y, and z. It's the same as using the row operation. Are we okay? So here I'll try to make this point 0 and this part also 0 in order to get a simplified equation so that I can solve it easily. So what do? I can choose to perform the row operation by saying on row 2, I'm going to say row 1. I'm going to perform the operation where I'm going to multiply or say row 1 minus 3 times row 2. And on row 3, I'm going to say row 1 minus row 3. This is going to work. So meaning row 1 is going to remain the same, which is 3, 1, 3, 0. Row 1 minus 3 times row 2 is going to leave us with 0, -20, 0, 0. And row 1 minus row 3 is going to also leave us with 0, 0, 0, 0 in this form. Are we okay? So performing the row operation, this is what I have now. Do you see that? So I still want to change this -20 to 1. What do? I can move forward and do another operation by saying I can also simplify row 1. So row 1, I'll say 1/3 of row 1 and also multiply row 2 with -1/20 of row 2. Row 3 is going to remain the same, which is 0, 0, 0. So I'll just multiply root 2 by -1/20. That is going to leave me with 0, 1, 0, 0. And 1/3 of row 1, that's going to leave me with 1, 1/3, 1, and 0. So looking at this, we can now derive the formula from this. expression. Are we okay? So let's look at how we can do it. So from this matrix, can I write that looking at the third row, nothing is there. On the second row, I have only 1 here, which represents the y. So can I say the y1 is equal to 0? This idea can be obtained from the Gaussian elimination or from the Gauss-Jordan elimination. Once you check out for the previous episode, you understand it. So our y1 is equal to 0 from the second row. And from the first row, can I say x1, which is this one, plus 1/3 of y1 plus z1 is equal to 0. Are you okay? So now we are going to put in the values and check it out. Or we can also try to simplify the equation. We already know the value for y1, which is 0. So once you put in the value of y to be 0 here, you're going to get x1 plus z1 is equal to 0. This implies that we can also say x1 is equal to negative z1 and x1 on z1, that is going to give us negative 1 on 1. This means the corresponding value for x1 is negative 1, that for z1 is 1. And we are going to say our x1 is negative 1. We know the value of y1 to be equal to 0 and z1 is positive 1. Are we okay? So we can conclude that for the eigenvalue lambda is equal to negative 2, its corresponding vector, which is x1, y1, and z1, is given us where x1 is negative 1, y is 0, and z1 is 1 in this form. Are we okay? So we are going to do the same thing for when lambda is equal to 6. So let's look at it. For lambda is equal to positive 6, what is the corresponding vector? So straight away, for lambda is equal to 6, we are going to have also this minus lambda I. This is the vector is equal to 0. A minus lambda I, this is the expression that we have. We have 1 minus lambda 1, 3, 1, 5 minus lambda, and we have 1. We also have 3, 1, and 1 minus lambda. Since this is the second part, we can say our vector is x2, y2, and z2. Everything is equal to 0. Let's try to put in the value of lambda is equal to 6, and we are going to get this matrix that is going to be negative 5, and we have 1, 3, 1, negative 1, 1. We have 3, 1, and negative 5. Multiplying the same x2, y2, and z2 equal to 0. Let's try to use the elimination method again here. So here I'm going to combine the matrix negative 5, 1, 3, and that is equal to 0. We also have 1, negative 1, 1, that is equal to 0. The third row, 3, 1, negative 5, and that is also equal to 0. So here I want to still perform the row operation. So what I'll do is I want to swap row 1 and row 2. So in swapping row 1 and row 2, that is going to give us, so row 1 is coming to row 2. 1, negative 1, 1, 0. And row 2, that is going to be negative 5, 1, 3, 0. Row 3 is going to remain the same, and that is 0. So I want to again perform the row operation here on row 2. I want to say 5 times, because I want to convert this 5 and 3 to 0, I can say 5 times row 1 plus row 2. And row 3, I'm going to say 3 times row 1 minus row 3. So once I obey this formula, row 1 is going to be the same to 0. And row 2 is going to give out this element 0, negative 4, 8, 0. Row 3 is also going to be 0, negative 4, 8, and 0. Looking at this, we have 3 equations to row 1, row 2, and row 3. Row 2 and 3 are the same. You can pick any of them and do the analysis. So from the equation 3 or row 3, can I say, because I have negative 4, that's for the y2, plus 8, that was for the z2, is equal to 0. This implies that my 4y2 can be equal to 8z2. Is that right? Yes. Meaning y2 on z2, that is going to give me 8 on 4. And this can be 2 on 1. Meaning the value for y2 is 2 and for the z2 is 1. So I can make here y2 is 2 and z2 is also 1. Now I can put in this value into equation 1 and get the value for x2. So let's look at it. From equation 1, we can get our equation as, so we will look at this. This is our equation 1, the first row. Meaning we can write it as our x2 minus 1 multiplying, so that would be y2 plus z2 equal to 0. We already know the values of y2 and z2, so that means x2 minus, this is 2, and plus 1 is equal to 0. Therefore, our x2 is going to be equal to a positive 1. Are you okay? Therefore, we can also conclude that for the eigenvalue equal to 6, its corresponding eigenvector, which is x2, y2, and z2, is equal to 1, 2, and 1. Are we okay? So we have this as our corresponding values. So we are left with, for lambda is equal to 3. We've now seen the corresponding vector for 6. We also know the corresponding vector when it is equal to negative 2. So let's look at it when it is equal to 3. Let's look at how to find the eigenvector. Now, the same approach, we are going to also start from the expression a minus lambda I. The vector is equal to 0. So we already know the expression for a minus lambda I, which is 1 minus lambda, 1, 3, 1, 5 minus lambda, and we have 1. This is 3, 1, and 1 minus lambda. Since this is the third part, I'm going to represent the vector as x3, y3, and z3. Everything is equal to 0. Now we can put in the value of lambda is equal to 3, and I'll start with the elimination method. Are you okay? So putting in the value of lambda, this is what we are going to get. And this is going to be negative 2, 1, 3. We have 1, 2, 1. We have 3, 1, and negative 2. That is going to multiply S3, Y3, and Z3. Everything should be equal to 0. So now we want to combine everything, that is negative 2, 1, 3, going into 0. 1, 2, 1 going into 0, and 3, 1, negative 2 going into 0. So here I want to perform an operation. I want to swap again row 1 and row 2. So swapping row 1 and row 2, I'm going to get 1, 2, 1, 0. The reason I always want to get this first place to be 1 is it helps me to multiply and get the zeros so easily. Are you okay? So this is also going to be negative 2, 1, 3 into 0, and this is 3, 1, negative 2 into 0. So there we have this. So let's try and see what we can also do with the next part. In order to simplify it, I can say I want to perform an operation. On row 2, I want to say 2 times row 1 plus row 2. And on row 3, I want to say 3 times row 1 minus row 3. Row 1 remains the same, 1, 2, 1 into 0. Performing the operation on row 2, you are going to get 0, 5, 5 on 0. And row 3, that will be the same, 0, 5, 5 on 0, like this. So equation 1, this represents equation 2, this represents 3. So I can choose any of row 2 and row 3 such that I can say my 5y cubed plus 5z cubed should be equal to 0. This means that 5y cubed can be equal to negative 5z cubed, and y cubed on z3, that is going to give me negative 1 on 1. This means that my y3 is negative 1, my z3 is positive 1. Now from equation 1, I can put in the value. This is going to be s cubed plus 2y cubed plus 1 is equal to 0. And this means s cubed plus 2 by negative 1 plus 1 is equal to 0. And s cubed is also going to give me 1. So I can conclude that for lambda is equal to, this is lambda is equal to 3, we can also find its eigenvector. And its eigenvector x3, y3, and z3 is going to give us 1, negative 1, and 1 for that. So it's quite interesting. You should always find for the lambda values and find for its corresponding eigenvector. Thank you for watching this episode. See you in the next episode for the next example.